because the title is Sustainable Transport and the Green Deal. We spoke about the Green Deal, we spoke about the challenges of the railway, we spoke about the need for the increased competitiveness of the railway, and it will not be possible without finding the way how we can run the rail services in even more green way. So electrifying railway, finding the measures how to be energy efficient, so how to meter the energy consumption, but also how to find the alternative means for the propulsion instead of the diesel on the non-electrified lines by the means of hydrogen on the battery-powered trains. And I'm especially happy that we will start our session with the speech of Carlo De Grandis from DG Clima. Carlo, I hope that you can hear me. You are online, that we can hear you as well. Great, great.
I do, but I was told to not to open the video in order to have to share the screen directly with the presentation.
Well, I believe, Carlo, you can show your face now, but of course it's not me. It's the IT techniques who should provide us with the necessary service. But we can hear you well, and I hope the presentation also is going to be on the screen soon.
Hopefully. Okay, let's start with the presentation then.
We've been instructed to wait one moment, you know.
Okay.
I'm not sure whether it's the best demonstration of the IT for the ICT, but...
Well, but I've got it open. I can share it myself.
Oh, I mean, it should be...
Carlo, just one moment, please.
Yep.
We are just going to...
I'm briefly attending indeed.
Everything goes well. Thank you.
So now we can see your presentation. We cannot see you, but...
Oh, apparently I see myself in a small window on the
and
top.
now we can see you, but not the presentation, you know that.
Oh, you have to choose. I mean, you can't have it all, you know.
No.
And honestly, considering also the offices, I mean.
You are sitting in your office somewhere at DG Clima
Yeah,
now.
today it was. I booked the office this day because we can maximum go once per week in order to appear more professional, but actually it's rather dumb in terms of perspective.
Good,
so
good to see you, and I hope to see you also in person soon.
Maybe one day, let's hope.
I really do hope. Okay, Carlo, so we have a presentation. We have you on the picture. Now you are smaller than before, so we can see both you and the slides. I suggest you go ahead and you have some 10 minutes to present your speech. Carlo, the floor is yours.
Okay, thank you. So I'll go sharing mine maybe so that it's rather smoother in terms of...
Can you switch on your video so that we can still see you?
Oh, okay, yeah, sure. If it doesn't...
No, it doesn't harm it. We will be happy to see both you and the presentation.
Okay, let's start, because yesterday we make some trial and we are
recommended... No, now it's perfect. Now it's perfect. Go ahead.
Okay. So let's go on the presentation itself. Here we are talking about, of course, the EU Green Deal, which is the big framework for the digital and ecological transition of the Commission on the green side. And it has quite something to deal with sustainable transport, as we see. Well, now, the Green Deal, or EGD as is often called, is quite wide-ranging, so it concerns every sector, including agriculture, how we eat, how we consume, how we involve citizens, etc. But there are three key elements which have lots to do with transport. First and foremost, investing in more and sustainable and smarter mobility, because digital and green are always combined in order to deliver efficiency. Promoting clean energy, which is then mainstreamed in the transport sector, which is now relying on oil, most of all, with the nice exception of railways, and eliminating pollution, which is in urban areas mostly determined, as we know, by transport. And in order to do so, the main package which has been launched now and will receive a second substantial backing now on the 14th of December is the so-called Fit for 55. Which is a comprehensive package aiming at delivering actually the minus 55% of greenhouse gas emission by 2030, which is a steep progress, which is called a steep progress, which involves everything, as you can see, from the use of soil, forests, etc., emission trading, energy efficiency, boundary conditions such as the energy taxation directive, but also the carbon border adjustment mechanism to ensure that there is no carbon leakage, so that if we tax carbon here, the polluting industries just go beyond the border, and then we import polluting element. No, this is taken into account into the picture, but also all the new fuels for transport, for land transport, aviation, maritime, and so on and so forth, and of course renewable energies and less energy consumption with the energy efficiency. Within this framework, this policy mix, if you wish, is a package because it's bound together in order to work. It includes lots of pricing, which is internalization of external costs, including ETS, and we'll see how it provides a level playing for the sector, which has been called by, and rightly so, by the railways. It includes specific targets at national level for sectors which are falling outside ETS, like the effort sharing regulation, for the way we use soil, how much renewable energy we produce, how much energy we consume, etc. And stricter CO2 emission for cars and vans, for instance, which will have to become zero emission by 2035, and all the accompanying infrastructure, but also support measures for those who are affected by the transition, including the social climate fund. So this is a whole package which we cannot take something out and let it work and achieve the results. It's highly interconnected. In this, the ETS, which is a major internalization of the external cost of greenhouse gas emission, will be linked to transport. On the existing ETS, we have the ending of free allowances for aviation, and maritime transport will be included. This is controversial on transshipment, but still it's a step forward. And we increase the ambition to go to not to -43, but -61 by 2030. But aside, so this is quite strong and will incentivize zero emission mobility. Then we have the new ITS for road and buildings that will affect the road transport with an objective of emission reduction of 43% by 2030, and which will feed also the Climate Social Fund in order to compensate those affected. It's not just a compensation, it's allowing them to migrate or to benefit from low emission modes. So this is something that can encourage also modal shift towards rail and local transport, for instance. In general, transport decarbonization is very complex. So it involves, of course, the goal is not 100% for transport alone, because it's very difficult as a sector to decarbonize, but minus 90% of net greenhouse gas emission at 2050. It involves lots of measures. You'll see two of them, 10T Urban Mobility Framework, that wants to incentivize the modal shift towards, for instance, railways and low carbon transport modes, but of course cleaner fuels for all the transport modes through Renewable Energy Directive, Fuel EU for maritime, Refuel EU for aviation, cleaner vehicles for light-duty vehicles, it's already out, and next year we'll have a new standard for heavy-duty vehicles, progressively phasing out more polluting vehicles, but also all the alternative fuel infrastructure provision through the alternative fuel infrastructure regulation, and also the availability of smart charging in buildings through the energy performance of building directives. In this framework, the vision is, what is it for railways? Well, railways already emit almost anything. In terms of direct emission, is 0.5% transport. So the idea is not much just acting on railways, but using more railways and providing more capacity for railways in order for railways to contribute to this objective. And in fact, this is also echoed by the EU strategy for sustainable and smart transport. We have an overall new package of TSIs, and you've been talking about some of the novelties that will be introduced this morning. We have the principle of internalization of external costs, which you have already seen in ETS, but will be pursued for other emissions than carbon in the future. The objective of doubling the traffic of high-speed rail by 2030 and tripling it by 2050, which is very ambitious. And this is on the passenger side. On the freight side, we have anyhow a main broad objective of shifting a significant share of the 75% of freight transport by road towards railways and inland waterways, and revising the framework for multimodal transport in order to make it more appealing, but also to increase rail freight by 50% at the horizon 2030 and doubling it at 2050. So there are strong ambitions for railways, and for this we will need more rail infrastructure capacity. And you know, I love this scheme which I've already presented once, saying that we are about to move away from the current uncertainty principle of very, let's say, discrete knowledge of more or less in which block the train is, to a situation where we will know all the actual train speed, position, its train integrity status, and braking performances. And that all will feed also through AI efficient movement via ATO. And this is expected to increase by something between 30 and 50% the capacity of the existing infrastructure. And that's where you are actually working on, notably at the horizon 2022. But we have also enhancing the integration of renewables, renewable energy, of course, in railways, and enhancing energy efficiency in railways. So, of course, electrification per se is to be widespread, is supported also through the recovery plans, and is still deployed. And having an increased share of renewables across time, they will have to pass the 40% by 2030. This electricity will be greener and greener. Then we have important savings expected also from ATO due to better speed, performances, and low costing, which are expected to be between 20 and 40%, which is a lot. And then new traction technologies will further also decarbonization. We've been talking, I guess you've been talking about hydrogen, which is already a mature technology for passenger transport today, but you have hybrid electric batteries which can be actually charged under the catenary, or hydrogen electric, which are very promising. So we expect new standardization process on this to be brought about soon, thanks also to the preliminary works in shift to rail, but also new concepts arising for stations as energy hubs in order to provide energy storage or reuse of energy in other transport modes. And with that all, we are convinced that railways can contribute significantly to the decarbonization of transport, more and better railways. And this is the last slide, just to recall that decarbonization and greening will attract more and more funding and financing via the environmental and social governance and corporate reporting, that it will shift substantial amount of money in terms of investments, thanks also to taxonomy, towards what is actually green. And luckily, railways are one of the main targets for transport, if not the best one. Thank you all for the patience and for this very broad overview. I hope I haven't bored you with these too many details, but you know where to find me.
Thank you very much, Carlo. I mean, it was very interesting. I would definitely come back to the issues related to the internalization of external costs and the new ETS. So big applause to Carlo. Thank you. So stay online, because we will have the session lasting for another hour. So we can follow that, obviously. But you also made a nice bridge to the next speaker, Paul from the TUC Rail, who should be with us today here. And he will be talking about the battery trains. I'm especially interested in his view on the issues related to the regulations. So what kind of regulation we have a micro here on, so you can speak online like that. Thank you.
Hello, everybody.
What should be the issue of the regulation and standardization of the battery trains? I will be very much interested.
Okay, I hope it's not too boring.
Oh, I mean, it's just that you have 10 minutes, because I saw that you have 20 slides, so please be careful.
I will go quickly, but
Good, thank you.
Okay. So yeah, you can go to the next slide. This is just something on myself. I'm an infrastructure guy. I'm from the overhead contact lines, so mechanics. It's not ICT. It's a lot of energy. It's dangerous. Okay, and involved in many projects. Yeah, next please. I can see it's not very readable. We have two problems, challenges. Legal challenges and technical challenges. We have, of course, the TSIs and parts of the European standards referenced in the TSIs. And of course the RIMF. These are legal requirements. And then we have some far more detailed and elaborated standards from UIC, very old leaflets, new standards, revised standards, and even on IEC level, of course. So, but these documents are not written for trains with onboard energy storage batteries, for example. And that's a problem. Next. So we try to tackle this in two ways: the legal problem and the technical problem. On the left-hand side, you can see that we started early this year in March with a new, let's say, ad hoc joint task force from the infrastructure managers, EIM and CER, and of course CER is also integrated companies. Eptola is also represented, and NB Rail. And then you can see some companies who are actively involved in trying to solve the legal problem. Unfortunately, Unife did not yet participate. There is clearly interest from them, but they judge it too early. And then on the technical level, there's a new working group 25 trying to develop a new technical specification for Senelec. And this is about, it's not the same scope. This is about infrastructure, because before it was stations, and for dedicated contact line sections. So you can go to the next slide. I will show some examples of these Senelec solutions. Yes, next please. Yeah, it's more or less the scope of the standard. So you can have modified existing OCL systems to charge the train, which will not necessarily be TSI compliant, but they will use the power supply from the existing systems. Then you can have, let's say, large new island sections. This means this is a new electrification. This is completely TSI compliant, but it's another start for a new network. Then you can have some medium islands, not TSI compliant again, and then the short one, which is on the picture, nice picture from a German town, Tübingen, where you can see just, I know if you could, there's no pointer, but this is just a few meters of overhead contact line, a rigid one, and then another one over there, so you have two ones, and that's it. That's a very short island where the train, this is obviously a battery train that can charge. And here you can see the substation. This is a substation connected to the city grid. Yeah, that's technically, but it's all about overhead contact lines, nothing else. Next. Yep. Then back again to the legal problem and the task force for change request 350 on the TSI. TSI, not only TSI Energy. We had a key objective on the, of course we want to support the Green Deal, everyone wants to support the Green Deal. Short-term objective that was to allow full charging of trains, and there was a main problem that's current at standstill. If you want to charge battery trains by the most obvious thing, that's the pantograph on top of it, of the train, then in the previous TSI there was only a requirement for the old trains to charge for DC systems, and so we opened it up for AC systems, but the final proposal is still to be discussed within ERA. We were in a hurry, we introduced it in April already, but as you all know, TSI will be revised next year, and there is a process to be followed, so it's still under discussion. I hope we can open it up for the battery trains that we can charge them at standstill more easily by the pantograph. And then you have the more long-term objectives for not TSI 2022, but the next TSI afterwards. Yeah, next please. But first we need to know what the trains want, because we can build a lot of infrastructure, But if you do not know what the trains want and need as battery power, then you know where. So we all know the picture I showed is a BMU, a battery EMU, so with 2 megawatts or something around that. But there are other examples with up to 5 megawatt of batteries. This is within a special tender. And this is an example for a Norwegian very long railway line where we can reduce electrification up to less than a third of the total length of the line if we could use these battery trains, which obviously would reduce enormously the infrastructure cost. Okay, thanks. That's next, yes. But then we run into trouble in the existing legal documents because there are some things written that energy, so the overhead contact line has no problem feeding a train up to 2 megawatt. We do not, trains up to 2 megawatt, they do not need a power or a current limitation. Because we said there is a direct link, the overhead contact line is able to provide that power easily. No problem. So we wrote that in the TSI. And that's the definition also. You can see that the scope is limited to the contact line system, okay? By using pantographs. I will come back on that later because this 2 megawatt is a problem. We might need power limitation far below that. And then again, the short-term objective that we try to introduce in the TSI is for the current at standstill for DC systems. Now we opened it up for AC systems also because battery trains charged under AC systems will need a lot of more energy than the actual trains we know now. Next. And these are all the possibilities. If you can see, all the technical possibilities at best can deliver 2 megawatt of power. They cannot deliver more. You have the current collector, so you have the four target systems. And you can see power at standstill is very limited. So this is about 30 minutes that the train must stand still to charge. And then it can only have 2 megawatt in the 25 kV system. In the others it's less. And then the other solutions is just by a plug. You have the first UIC 552 plug, which is a very old system, a little bit expensive, but nowhere near the 2 megawatt. Don't be fooled by the yellow markings. And then you have an industrial plug, which is used. This should be here in the room also. So these plugs, these are used everywhere. And then there's even a new type of plug. What do we want? We have four charging possibilities. What do we want? What do we want to standardize? We don't know that. Okay, this is an example of such a newer shore supply. And also in Germany, the second bullet, they are talking about a 5th power supply system through the pantograph. So obviously, TSI already has 4 existing target systems. We're not going to add a 5th one in the TSI, but it might be a good technical solution. Why not? Why block that? We must be careful to standardize too early and block future solutions that might be interesting. And then you can see, so the plug solutions are only when the train is really stabled overnight. Then these plug solutions have sufficient amount of power to even charge a battery train completely. Next. And I like this picture. We are not standardizing new things. This is a nice tram from maybe 100 years ago, something like that, in Paris. And you can see here a nice charging station and the cable feeding the tram. So, next. Yes, I don't know if the animation works. This is about the second plug solution. So this is an industrial plug, a 400 volt plug, and then you can see, I hope the message came through. With this system, we can be future-proof for more type of trains, also with fuel cells, for example. That it does not need the traction converter, absolutely. So this is maybe more flexible than the UIC 552 plug. Okay, next. This is some standards. Then you can read if you want them. Okay, next. Good. But there are a lot of standards involved, and we are trying to include battery train operation in these standards. Yes, next please, next. Again, to the current at standstill, what we did up till now, there are a lot of tests being done because it's a problem to charge battery trains. You can see there's a recent report from RSSB in the UK. There has been tests done in Germany, in Belgium, Italy, France, etc. And because to charge the battery to the pantograph, we need to know what are the margins. I believe we can provide more power through the pantograph, but the values written in actual documents, TSIs and standards, are of really safe margins. They allow very safe operation of the trains, and I believe it can be higher. So go to the next, then we could see. This is a nice example. You can read all the text, but what they did here, this is something you will never see on the railway lines now. These are two rigid overhead contact beams. One is installed often, in for example, Berlin main station. You can have that, but this configuration would allow easily 220 amps. So this more than doubles the actual requirement without problems. And then we can have a much more power under the to be provided to the trains. Of course, then you have all the circumstances we can with the tests and that differ. Next, please. Yes, this is an example from SNCF, but then again, these are not standard pantographs. This should be allowed to for the battery train. With these pantographs, they are not allowed in many countries, but you can see 1,000 amps. We can provide much more power to the train by that means. Next, just an example. Okay, Belgian examples. So we have the limit here. Then it depends on your national circumstances to which temperature you can go when charging at standstill through the pantograph. So the upper limit is, of course, this is the standard, and then the lower limit, that's you have to calculate for each country. Yeah, next. So this is an example. You can read all the messages, but keep in mind this one. So this is the limit that we can use. We can see it's more than 200 amps, even in really bad circumstances, because this is also a worn contact wire. So there is a possibility to increase the amount of power at standstill. That's the message from these three examples. Next. Then about charging strategies, because we know when a train is at standstill, it can have during a large time a limited amount of power, but during a short time it can have much more power. And then I come to the ICT field. Then we need communication with the trains and infrastructure. We need to know what the state of charge of the batteries is. We need to know which train is going to depart first. We have to know a lot of things, and that's where the ICT comes into play. Yeah, and then of course, another technical, I'm a technical guy, sorry for that, but we need a train that's just plugs in, let's say, through his pantograph, is demanding on the infrastructure side, and that's why the Germans want to do 50 Hertz on their system. This reduces the inrush current. But of course, all these things are not foreseen, but the standards can do that in future. Next. And this is how it looks like. So you can see clearly, depending on your configuration, this is standard here, 30 minutes. That's standardized. But if we go in short times, 2, 4, 6, then we can provide much more power, and all these values go up, and we can be more comfortable in charging these trains. The next, and then something else. We always talk about batteries, but there are other technologies, so we should be careful, because these technologies allow much faster charging or discharging also. So how do we coordinate infrastructure and the trains? Because there is the fourth railway package. We cannot build an infrastructure for one type of train. We should build it for a range of batteries or energy storages that another train in maybe 10 years' time can also be charged and run the same timetable as the one we had in mind when designing the infrastructure. And that was it. I thank you for your attention, and I think...
Thank you. Thank you very much, Paul. That was impressive, and I'm sure that we will come again to the questions. So stay with us if you wish, then you can sit here or you can sit on the first row, up to you, whatever would wish or would you will feel more comfortable with. So many thanks, and now yes? What? We can go ahead, yeah, okay. So that was my plan. Now we go to the next presentation, which will be delivered by Philip and Yannick, Alstom SNCF. I don't know who of you is going to do it. Do we have both of you? Perfect. Perfect. Welcome on the stage. You can use this micro, that micro, up to you. Okay. Which one you wish? Well, you can be here, of course, absolutely. So I move out and then you move in. And we will learn more about the hybrid and hydrogen trains.
I hope so.
Oh, we do hope. Go ahead, please.
So, you can start, thank you. Okay. So, I am Philippe Clément from SNCF, Rolling Stock Engineering Department, and I am with Yannick.
And I'm Yannick Leguet. I'm working for Alstom as a technical director for business development in France.
So you can start the presentation, please. Okay, that's me.
And that's me.
That's him. That's him. So first of all, I think we will go quickly on that because you already saw quite a lot of time that topic, that the railway system in general is emitting not a lot of CO2 emission compared to its market share. So in France, it's 0.3% of CO2 emission from transport sector, but almost around 10% of the market share. Just one point here I wanted to notice for the airplane sector. In fact, we should double the emission because it's just take into account the CO2 consumption and not, for example, the consumption trails, and we know that it has an impact also on the global warming. For the road sector, at the moment in France, they take zero CO2 emission for electric vehicles, so it's wrong also. So please next. So why this sector railway sector is so efficient? In fact, it is because we have the physical laws in our favor. The wheel-rail contact is very efficient. We have also very efficient aerodynamic system, and we have, from the beginning, a very huge load capacity. And in the past, they knew that they needed only one horse to run a coach on a rail compared to 12 on the road. So it's very efficient. And this system is already very electrified, transporting a lot of goods and passengers with a very small amount of trains. So it's energy efficient and also material efficient. So why do we need to decarbonize? If you see that, you can wonder. So the answer is there. the CO2 emission is linked to many parameters. You have them in the equation above, and we know that from the studies which have been made, all the levers must be activated to reach carbon neutrality in 2050. It means that we have to shift a part of the transportation from road to rail. And also we have in France quite a large amount of lines which are not electrified. And also for regional trains, half of them have a diesel engine. And all of that is emitting almost all the CO2 emissions from the regional trains. So for all of that, we want to increase our market share. We have a large amount of non-electrified lines using diesel. We know that we need to decarbonize this to reach the goals of neutrality in France. And there is also one other point is the air quality. With diesel, we are emitting NOx and PMs, and this is also a concern. So next. Thank you. So what are the solutions from the point of view of SNCF? So we can still decide to continue with the combustion engine and try to feed them with more sustainable fuels like B100, it's biofuel 100. So it's issued from rapeseed, as you see in the picture, but there are also other options we have studied. So in France we are testing in real trains the biofuel, and we are studying the other options. And on the right of the screen you have what is also possible to do is to go to hybrid trains, battery trains, hydrogen trains, and you will see all these options with Yannick just after that. I would like to mention that these solutions are developed with a region in France, and especially with one very engaged region in that topic is the region of Occitanie, where we are today. And they are very active on this topic. So you see, I put the CO2 emission of all energy alternative we have. So the beginning is conventional fuel is the number under the combustion engine, and over there you have some numbers, some figures, and some of them are under discussions, and of course they will have some changes, especially in the hydrogen, which is quite new, and we are wondering about the real CO2 emission of hydrogen, according to where you are producing them and how. So this is my last slide. It's just to say that this is not only a CO2 topic. When we want to change the energy, of course there is the environmental impact, but we need solutions that are on the market, so available, with the good performances, expected performances, and we know that we will have to change the way we operate trains, so we have to adapt all of that. Of course, there is a question of cost, how much we have to invest, and how much will cost the maintenance of the train, for example. And we have to link that with the local strategies, because some regions are investing on one energy rather than on the other one. So of course the trains in these regions will be fed more with that energy than another one. And there is also the question of employment generated by all of that. So I let the floor to Yannick now.
Thank you. So as I would say a rolling stock manufacturer and system provider, in Alstom we have made the choice not to I would say favor any of the two technologies that we have available today to reduce the CO2 emission. That is, in fact, to reduce, as already said, the 0.5% of CO2 emission linked to railway industry or railway transportation, we have today two major technologies available. One is the hydrogen, the other one is the battery trains. And if we want to be ready for the day we will have to renew the fleets of actual diesel trains, we have to play on the two grounds. We have to not favor any technology, but to be ready to demonstrate the ability of the two technologies to replace tomorrow the diesel train. So we have launched projects, and we started with the very first one was the Island, which was the first train running with hydrogen. So the hydrogen Island was put into service in 2018 in Germany. It has run for 18 months with passengers. So it has run for daily operating services. So the passengers on the platforms were waiting for a train, and they didn't know if the train that was coming was a diesel train or hydrogen trains. So it was completely transparent for the passenger in terms of services, availability, and reliability. So the train was put in service in 2018. So this is for fuel cell. For battery, we have sold a battery train based on the Coradia Continental family. So it was also sold in Germany. So we sold 11 of these trains. We have started together with SNCF and 5 regions in France a project with former Bombardier teams to replace diesel engines on AGC with batteries. So this was signed beginning of this year, and the target is to deploy this on nearly 300 trains, potential trains on the SNCF fleet today in the regions. One of our major success was also this year to be able to propose to 4 regions in France, which were Occitanie once again, with also Grand Est, with Bourgogne-Franche-Comté, and with Auvergne-Rhône-Alpes. We succeeded with SNCF to launch this project of Réjolis B-mode hydrogen, which is a train which is able to run under electrified lines with pantograph raised and with the catenary, and continuing its trip on non-electrified lines with using fuel cells, to be in a low emission mode. We also sold this year another project in Italy, which was called Coradia Stream. So we sold 12 of these trains in Italy, which is a monomode fuel cell train, based on a range of Coradia Stream. And more recently, we succeeded to step forward in the Eversholt program, which is to retrofit trains in the UK, in Scotland, to be able to propose to a leaser to transform former electric trains in fuel cell mode trains to run on non-electrified lines. So we still have some other projects today that are running on the left-hand side of this slide, but we have many projects ongoing today regarding both diesel fuel cell trains and battery trains. Next, please. So the following slides will be the details of this train. So this is a Coradia Continental BEE Muse, so which is able to run 80 kilometers, which is more or less what we decided both in Alstom and former Bombardier to take as I would say the baseline to be reasonable in terms of the volume of battery, the volume, the number, and the load of batteries that would be loaded on the train to run on non-electrified lines. So 80 kilometers looks to us a good rating for the autonomy. So next, please. So this is the Coradia Island, so full fuel cell trains, which autonomy is not 80 but 1,000 kilometers. So we are not working on the same scales for autonomy. So this train was once again put in operation for 18 months. It has been sold to LMVG and to RMV in Germany. So we have 41 of these trains already sold. So you see in the picture the fuel cell refueling stations that are under constructions. The train will be delivered beginning of next year, around between April and March next year. Next slide, please. The Coradia Stream in Italy will be delivered also for the first one in 2022. for the test. It will be in operation in 36 months. Okay, so this is a 6 + 8 options. Next, please. This is a Coradia polyvalent, so once again a B-mode train with electrical and fuel cell. It will be built in Reichshofen, the site that has been sold recently to, or which is about to be sold to the CAF. The project has been signed, but Alstom will still be present because we will be Alstom responsible to make it run and to make it a success for the regions and for SNCF. So the planning is to have this train in validation in 2023 and in operation by the end of 2025. Next slide, please. So this is the AGC battery. So this was signed by XBT before the convergence of the two companies was done beginning of this year. So this train will be in operation in 2024, and the first train will be retrofitted in Crépin by spring next year. Next, please. So for the AGC, so we have 5 regions and 5 trains. So we'll have 1 train for each region to run the test before going to the deployment phase. And last is what we already mentioned. It was the project of Aventra in Scotland, where the leader, which is called Eversholt, proposed to us to modify the electrical trains to be fitted with fuel cell modules to make them available to run on non-electrified lines. So as you see, we have many projects, and we are once again working on the 2 solutions because we think that each solution, battery and fuel cell, will have their own, I would say, pertinent zone, and it would be, for us, it's much more easier to explain that we have the 2 solutions, so we do not favor anyone. So depending on each application case, in fact, we can choose the one or the other, and the worst thing will be to push for one technology which is not well adapted to the use case. We prefer to have the 2 solutions available and to propose the best use for the technology. Thank you for your attention.
It was really great. Thank you very much. And by the way, congratulations, Yannick, for the island, because you've been a winner of the Railway Award this year for the island hydrogen train. So you should have mentioned that as well. Thank you. Now we are coming back to the infrastructure with Bart, who is going to explain us how can the energy metering help the energy saving, which is of course an essential component if you want to be greener. Here is your microphone.
Thank you. Hello. Next slide, please. So that's me. Okay, next slide. So here are 3 examples of a passenger train, high-speed train, and freight trains. It's on the same line, the same. And we see a huge variation in the energy consumption of these trains on these lines. Hello? Yeah.
Switch your, take another one. With the table, the microphone on the table, change it. Battery issue.
Okay, better? It means that if you're running on the same tracks and you have such a difference in consumption, there is no return on investment for automatic train operation or whatever eco-driving. You need to have measurement to be invoiced correctly for your real consumption. Next slide. How can we do it? First, you have sensors or transformers measuring current and voltage. Then you need to multiply and integrate. Then you have the energy consumption, also during braking. Then we add the locations, because you need to know where consumption took place, as you need to be able to send it to the right infrastructure manager on which grid the consumption took place. Next, then this is altogether called an onboard energy measurement system, which is standardized in the 50463 series of Senelec, and now in the 62888 of IEC. So railway undertakings operate trains. Trains can have an onboard energy measurement system. That one sends the data system on ground. It's going up and down. Then data goes to Exchange. In Exchange, we're looking what were the GPS positions, and then send the data to the country where the consumption took place. Then we come in settlement. Settlement will have different functions. Next click. So first is validate, estimate the metering data. For that, we receive data from the railway undertakings. This can be your request of a train run, but also energy market, what was the consumption in the different substations. With that together, we can validate, estimate, but also allocate to the right consumer who has been consuming, and they can have free choice of supplier, so the data can go to the infrastructure for the grid fee and to the energy market for the consumption. It can be that it's still the infrastructure manager delivering the energy, and all the contract is passing by that infrastructure manager. You have the invoice. Next slide. So an overview in time of regulation and standardization. On the left you see the EMS, the meter on board, the communication to ground, the DCS collection on ground, and then the settlement, the handling of the data on ground. And now we're going to start history. 2007 was the first standard. 2009, a first UIC leaflet regarding the handling of the data on ground. 2011, the first TSIs. But the Senelec standard was still not yet ready. So they just copied in parts of the Senelec standard in an appendix of the TSI. Then 2012, the full standard was published, 5 parts: introduction, the energy measurement function, then the data handling system on board, the communication, and the last part was conformity assessment. 2014 was a new series of TSIs with on board, it was mandatory on new, renewed, upgraded vehicles. The communication to ground was not yet defined exactly, so it was regarded an open point between 2 TSIs, and the energy TSI had the data collection on ground. The rest was in the Commission regulation saying that 2 years after the closing of the open point, you shall have a DCS on ground and you shall have settlement able to exchange, validate, and allocate, and taking into account the legislation of the energy market. Then we are in 2017, following the open point request from Commission to ERA to Senelec. Senelec has adjusted the standard and has now a communication protocol for the communication between board and ground. That's 2017. Then 18, this was taking over in new Commission regulation and a new TSI updates. So you have to follow that one. And then we come to the dates. A DCS will only become mandatory next month, but the settlement further on became mandatory July 2020. It's a bit an oddity, but it was that way published. Then we are 2020, and then there is an update of the UIC leaflet. Now it's an IRS 9930, updating the role model and the settlement on ground. And then at the end, we have also 1 month later a sector declaration, and I will come back to that point also later. Next slide. So 9930, which is the role model on how metering should function, what are the different roles, how should data be allocated, how should it be transmitted, who should do what. So it's all the task responsibilities. So it has the actors that are the stickmans and the functions that are the blocks. And then the big black lines are the data flow between the functions. If you have the presentation afterwards, you can just click on that IRS 9930 and you will have the link to get it free from the ETF shop. And if you want to join the project, it's still possible. So everything is published, but we are now in a maintenance phase. So it has to get up running everywhere, so that's why we have this maintenance. Okay? The sector declaration has been approved by Allrail, CR, EIM, EPTOLA, ERFA, FedEc Rail, NB Rail, and UIC. So not Unife, again. He has left, so he should have been here. It has commitments for the RUs and for the IMs. There were also two aspects where we wanted change in the regulation. One is that there were deadlines that were too short, but Commission refused to adapt it, so it will remain the short deadlines. And the second point, we had a meeting with Unife this time a few weeks ago, and we have a joint proposal now towards ERA, and we hope it will become part of the next TSI revision. This is on trains with existing transformers, where it's much cheaper if we could keep these transformers, but they are not tested according to the 50463. They are tested according to standards of the electricity market. So you can't prove they are accurate at 1% or 5% of the current or at temperatures low or high. And there we have a compromise now, and hopefully ERA will put it into the, will propose it into the Commission implementing regulation that will introduce the changes in 2022. Okay, next slide. So these are the commitments, infrastructure manager and RU. So RU has a commitment on installing EMSs. We have put some values how much should be installed. If it's a new installed EMS on a new train, then it shall be fully compliant. If not, the non-compliances shall be stated. All new renewed EMS shall send the data as soon as possible to ground, and RU shall be able to deliver the train compositions. If we don't have train compositions as IM, we don't know who has consumed, and we can't make the link with an onboard energy meter because they use the European vehicle number as identification. IM shall provide the DCSs as requested and will use the deadlines from that IRS on the further sending of the data and use the protocols of that IRS. The IRS 9930 is using the same protocol of the same data blocks as in the 50463. So the same data block is used for communication from board to ground and further on ground. And IM shall enable a pragmatic approach to increase the possibilities of the RUs in the electricity purchasing strategy. As you see, this is a political sentence, and all relevant information is publicly available. Next slide. So we have a framework on energy metering and settlement. So now there is also return of investment possible to the RUs in consuming less energy. How can we, as infrastructure manager, help them? That will be the next slide. Can we send information in front to, for instance, avoid an unnecessary stop, an unplanned stop? How can we do that? So this is an example from Switzerland. So a train is running on the normal way, so you have a tight run going to the max speed, but then you have a double yellow and you have to stop, and you're entering a little bit too late in the station due to that unplanned stop. Just remember the values, 350 and 651, next click. So you see, by avoiding this unplanned stop, there is a huge decrease of the consumption, but also the train is arriving in time and not too late. So by running too fast or at maximum permitted speed, you're arriving later and consuming much more. But an RU needs to know this, the driver needs to know this, and he doesn't have to do it with a lot of tables and things like that and looking outside. He should get the right information on a tablet or on a screen in the cap. Next, yeah. So we published an IRS 9940, so also from UIC, and it has a protocol called the SFERA protocol, and it enables communication from traffic management towards a tablet PC on board. Why did we develop a separate standard? Because in Shift to Rail there was the ATO project ongoing, but that was just for ATO and just for ATO over ETCS. And we were afraid that we would losing too much time if we would wait, but they've understood in the meantime, and they're going to also adapt in the ATO over ETCS to not only ETCS and also to adapt it for driving advisory systems. and we are now having joint meetings with them to come to a joint standard, but that will be for the 2027 TSI. So two ways of communication, direct one from traffic management system towards the tablet on board, or by communication to a server of the railway undertaking or a server of a DAS supplier, and then to the DAS on board. And DAS is driving advisory system. Next slide. So how does it work? Each DAS has its own optimization algorithm. It sends feedback towards traffic management system. Traffic management system then calculates, are there conflicts? If there are conflicts, sends advices. Advices come back in a train path envelope. A train path envelope says you have to pass on that point, moment, and that moment. So it gives a time span where you can pass. It can also adjust the arrival time in stations, because otherwise you will have a conflict. If it's better to arrive 1 minute later, it's better to give that information. Next slide. And that's the last slide. So we're here in Toulouse. We're in the panel regarding the Green Deal. I'm just wondering how many of you has been coming by train? A lot, but for a railway, we're here on a railway meeting. It should have been more. Who is coming by plane? It seems to be nearly the same or a little bit more. And I just compared the values via Eco Transit from Eco Passenger from UIC. It's a huge difference on the travel from Brussels to Toulouse, and it's not that much difference in time. We came from Brussels yesterday, but you're just working one day in a comfortable seat in an SNCF train, and you're arriving here in the city. So why to go to an airport, wait there, go in, have such a table of 20 centimeters if you're lucky, and again a transport here, and maybe it took 4 hours less, but we have been working a full day, so we haven't lost any time. So thank you very much.
Thanks a lot, Bart. Thanks a lot. It was an interesting presentation. I mean, you can take a seat because we will continue, of course, with some kind of a Q&A session afterwards. Now I hope, because we have somehow the presentation will be completing your ones to be delivered by Domenico from INRIM. But is Domenico online? Can we
Yes, here I
hear
am.
and see Domenico?
Good afternoon, everyone.
How does it look like?
The last version, nice. No, 7, no. You uploaded the old one. Oh, no, maybe it's the, let me.
No, at least
7.
we can hear Domenico. That's
1 December. Can you, because there are two, no, this is the last, this is not the last one. There is another one, 7 of December. I saw in the list, 7, that one. Good.
okay, so if you, Domenico, you see your presentation, then I suggest you go straight to the point. So welcome on board of our session today, and the floor is yours.
Domenico, you confirm this is the right one?
Yes, it's the right. Good afternoon, everyone. My name is Domenico Giordano. I will present the contribution on title Accuracy of Energy Measures, the MARES project, next one. I'm a researcher at INRIM. Next slide, please. I'm a researcher at INRIM. INRIM is the Italian National Metrology Institute. And next, please. A few words about MARES project. It was a metrology project founded by the MPIR research program, and it finished last January. Here a list of outcomes from the project. Since such project involves many metrology institutes, one of the focus was to the development of new calibration services for energy measurement functions. The devices presented before by Bart that are placed on board train to measure the absorbed energy, absorbed and generated energy. So we develop calibration services for AC 50 Hz systems, for 17.7 Hz supply system, and even for DC supply system. And the upgrade was that such calibration systems are able to apply distorted waveforms to the energy measurement functions. Inside the project, we also developed the new tools for power quality monitoring, in particular for DC railway systems. And we patented an idea for the detection of arc event in DC railway system. We developed a methodology for the accurate determination of the power dissipated by braking resistors for DC supply systems and accurate onboard determination of the energy saved by the eco-driving. Next, please. In this project, I will focus on the meteorological contribution that we try to provide to railway community, that is the calibration and the periodic re-verification of the energy measurement systems. As Bart mentioned before, it is required to measure, to have such equipment on board train to measure energy. And so it's important to evaluate the accuracy of such devices and to perform the periodic re-verifications. It's important to evaluate the accuracy of such devices, not only under steady state conditions, it means under pure sinusoidal or DC waveforms, but also applying distorted conditions or for DC plus ripple waveforms. And here you can see the contribution that I described, I present here. We developed new reference setups for laboratory and onboard calibration of EMF for AC system and even for DC system. Next, please. Here you can see the structure for the calibration of energy measurement system, energy measurement function. For AC, both 16.7 Hz and 50 Hz system. The setup is constituted by 2 voltage and current amplifier. Such signals that are at low amplitude are amplified by voltage and current instrument transformers. So we are able to apply in the same time both voltage and current. So with this calibration facility, we can perform the calibration of the whole measurement chain that involves a transducer and the energy calculation function. Of course, we need a reference divider for the voltage measurement and the reference sensor for the current measurement in order to know with high accuracy the signals we are applying. And thanks to the low voltage generators, it's possible to apply not only sine waveform, but even waveforms with distortions. Next, please. Okay, and here an example of a possible upgrade of the system that can be applied in the laboratory for the calibration of the energy measurement function, even on board. To perform the idea is to perform the calibration and re-verification, the periodic re-verification of the accuracy of the energy measurement function directly on board by applying a phantom power. So we apply voltage and current but it's not a real power. But on the energy measurement function point of view, it's like to see the real power. In this way, we are able to apply reference signals that allow to perform the calibration. Here you can see the proposed setup for the AC calibration. Next, please. And of course, the system is able to generate the voltage and current dynamic that is required by the standards in order to evaluate in the point you can see here the accuracy of the energy measurement function under the dynamic operating conditions defined by the standard. Next, please. Here we move from AC to DC system. We developed a calibration facility able to generate voltage and current. You can see here that we are able to generate up to 5 kV and up to 2.4 kiloamps with an interesting high accuracy. And we are also able to apply disturbances like ripple, next please, to the generated signals. Okay, here the setup we have developed for the DC. We have a voltage and current, 2 channels. We generate voltage and current, and we apply in a synchronous way both voltage and current. And we generate the voltage by means of arbitrary waveform generation cards and amplifier that amplifies the voltage signals and the current signals. And we can also to apply such waveforms to integrated sensor that involves both voltage and current. So the peculiarity of this setup is that the current channel is floating from ground. And in this way, we can apply a phantom power that on the EMF point of view is the real power. Next, please. And here the amplifier we have developed for this setup, for the voltage amplifier and for the current amplifier, we are able to generate, as you can see, very high voltage, but for DC for sure is enough to reach up to 5 kV. The bandwidth for small signal is very high, so we can generate even ripple and transient events that could affect the accuracy of the energy measurement function. And on the right side, the current amplifier we have used for this setup. Next, please. And here the reference system that provide the traceability of the power for the calibration, the traceability to the national standard. For the voltage measurement, we use an accurate RC divider, and for reference current measurement, we use a wide frequency band with flux gate sensors. Next, please. Here you can see the possibility of the calibration facility to generate a real waveform. Here you can see the current and voltage we have acquired during one of the measurement campaign performed during MyRails project. You can see in green the current. This is a commuter train, a 3 kilovolt commuter train. The measurement were performed in Italy. And you can see the voltage in red, the generated voltage, and in black, the voltage signal provided by the EMF. You can see here that we can also generate the distortion, the transient event that can occur. And on the right side, you can see the result of the calibration for a specific case. Next, please. And the system for DC we have developed is also able to generate transient events like the arc, the conducted effect provoked by arc occurred between pantograph and catenary. Here you can see an example of voltage and current detected onboard train during an arc event. With the generation system, we can also generate such events that on one side can affect the measurement of the power and energy, but next please, on the other side, we can use this generation setup to characterize new possible functionality of the energy measurement function. In fact, one idea is to integrate in the energy measurement function other functionalities other than energy measurements, and for example, functionalities that perform the power quality monitoring, and by exploiting the communication between the energy measurement system and on board and on ground, it is possible to collect power quality indexes in order to perform, for example, predictive maintenance. This is the case, for example, of the arc event detection. Such devices can be exploited to perform the arc event detection, to collect data, and maybe to perform a predictive maintenance for what concerns the pantograph and the quality of the contact between pantograph and category. And this is finally, you can see here the new metrological capabilities that some of the European metrology institutes have developed in order to guarantee the accuracy of the energy measurement system. You can see the new capabilities provided by LNI, that is the French Metrology Institute, by Fundación para el Fomento de la Innovación Industrial from Spain, and INRIM was focused on DC calibration facility, and you can see here on the last column the accuracy we can provide. Next, please. Thank you very much for your attention and for this great opportunity to share the novelties on the metrological side for the railway system. Thank you.
Thank you very much, Domenico. It was really going to deep technical details, so maybe Bart will then be able to say a few words about it. Thank you, Domenico. Thank you. And now we are coming to the final presentation to be delivered by Denis and Julian from Senelec and IEC respectively, concerning the standardization of the fuel cell applications for railways. So I'm sure that we are going to learn even more about how to apply and standardize. The floor is yours.
Thank you very much. So next slide. So we'll talk about standardization of fuel cell application in railways. So yes, so Julien and I are working in Alstom, and we are both involved in the standardization. So Julien is involved in the joint working group in charge of two parts of the IEC 63441, hello, yes. And I am the secretary of IEC TC9, and I'm also secretary of Senelec TC9X, and we'll come back to that topic later on. Next. A few words about in the world. So in the Railway Technical Research Institute started to work on fuel cell hydrogen in 2001. And they developed the first hybrid train with fuel cell and lithium-ion battery in 2008. In Europe, so the ILINT, yes. So the ILINT, as it was presented before, was put in commercial service in 2008 to train, and the first commercial floor train was put in service in 2017. So there are lots of trains that are running with this technology. So next. ECTC9 is managing several standards related to rolling stock, fixed installation, and management systems. So it includes standards related to hydrogen. So we have we have 37 working groups working in these domains, and we have more than 700 experts in the different and worldwide countries. There are in fact two groups that are working on the hydrogen-related topics. There are first one, which is a joint working group, the 51. Why is it a joint working group? Because we worked, in fact, with technologies, and we have two parts, and this joint working group is managing two parts. We'll come back to that later. And we have a dedicated project team related to the part 2, which deals with the storage system. Just a remark on TC9 of IEC and TC9X of Senelec. So we have an agreement between Senelec and IEC in order to be able to reuse, I would say, standards. So we have the possibility to have a parallel vote. So when the IEC standard is published, it can be adopted as an EN IEC standard in Europe. And this is the path we will follow for these standards. So next. So what's the context of this standard? So the context is that for the moment, there were no standard for fuel cell hydrogen in the railway environment. So as you perfectly know, the railway environment has some particularities, such as some safety dedicated requirements, some specific environments, such as electromagnetic compatibility. And there are a world trend, which is, and we have seen that before, a request to have less and less CO2 emission. And there is an opportunity, which are the non-electrified tracks, on which currently diesel trains are running. And of course, fuel cell hydrogen is a very good opportunity to replace them. We have a challenge, which is a time challenge, because as you have seen, there are several trains that needs homologation, and we need to provide new standards for helping this homologation. Next. So roughly, this is the organization of the standards. So we have a generic standard which deals with the onboard energy storage system, which is the part 1 deals with a hybrid systems. This is IEC 62864-1, and we have a level. So this part is at the level of vehicle system interface and system interface, and we have a level of component for which we are working. So we have the part 1, which is related to the fuel cell power system in green. We have the part 2 related to hydrogen storage system. And we have the PT for that. And we have the part 3, which is developed in the joint working group with TC105, related to the performance requirement and test method. We have a part 4 dedicated to the communication between ground and train for the hydrogen refueling protocols. It is not yet started, but we are thinking about launching this standard in a few months. Next.
Thank you, Denis. So I'm fuel cell system engineer in Alstom. Sorry, and so I'm back to the development of the fuel cell system for the project presented by
Please utilisez le pupitre, s'il vous plaît.
Okay, this is better. Yeah. Okay. Yes, so I'm fuel cell system engineer, participating in the development of fuel cell system for the project presented by Yannick just before. And I am also managing the joint working group 51 to prepare the standard, so the part 1 and the part 3. So as explained by Denis, there will be four parts for this standard. First part will be dedicated to the fuel cell system propulsion. The second one will be dedicated to the storage, so compressed hydrogen storage used for railway application. The third one will be dedicated to performance test method definition and description related to the fuel cell power system validation. And as explained by Denis, there will be a fourth one regarding the communication protocol between the H2 refueling station and the train. Next one, please. Okay. For sure, you are much more than welcome to join and to participate with us to the joint working group. So this is a menu for the part 1. We discuss about, so we define the scope of supply and the description of the interfaces of the fuel cell power system with the train and with the environment. We also talk about design requirement and functional requirement to be sure that the fuel cell power system will be compliant with railway application. We also talk about the way to define the fuel cell power system performance and be able to compare one fuel cell system to another for railway application. There is also a chapter dedicated to safety and protection requirement, especially related to hydrogen management, to see how we need to manage hydrogen at train level, but also for refueling and so on. See how we can manage it properly and safely. Then there is also some chapters regarding protection for person, and then labeling and so on, and requirement for storage and transportation as well. Next one, please. Yeah. And so this is a functional block diagram for a fuel cell power system. So you can see in the middle the fuel cell stack. So just to remind, we inject hydrogen gas inside the fuel cell. We also inject oxygen coming from the air, and then we are able to produce electricity used for traction and to provide power to auxiliary of the train as well. We also generate heat and water as a byproduct of the electrochemical reaction. So this reaction takes place into the fuel cell stack, and we need a couple of subsystems to manage properly this fuel cell stack. So first, we need for sure hydrogen storage to store and then to distribute hydrogen. So this is the red circuit you can see on the diagram here. We also need to take the air from the environment, and then we need to compress with a compressor to push air inside the fuel cell stack. We also have a cooling circuit inside the fuel cell power system to properly manage the heat produced by the fuel cell. Then we have a power conversion. We have also monitoring and control system. So from engineering point of view, it's a very interesting system, because you can work about mechanical aspect, about power conversion, about hydrogen, about electrochemistry. So it's sometimes quite challenging, but it's very, very interesting. Next one, please. For the part 2, so this one is dedicated to the hydrogen storage system, and we focus for now on compressed hydrogen storage system solution, so mainly for 350 bars. And so we also define the scope of supply for the standard, and also we discuss about the environmental condition to be considered for sizing and design the storage system. We also talk about, for sure, safety and reliability for storage for hydrogen. And then there is also some requirement related to marking, relating to storage, transportation, and a chapter dedicated to validation as well. Next one, please. And so here you see the functional block diagram for the compressed hydrogen storage system. So in the middle, you can see the H2 tank assembly mounted on the train. And we have also, so here we store hydrogen at mainly at 350 bars. And we have a gas treatment unit able to go from high pressure to medium pressure to be able then to supply the fuel cell power system. And in addition to that, we have also a control unit to properly monitor and manage the system. And for the part 3, this one is dedicated to a performance test method for the fuel cell power system. And then we discuss about a typical power profile for railway. And we try to define a standard power profile to assess the fuel cell performances for a given profile. And we discuss how to measure the key characteristic of the fuel cell in details to be sure to have a common view to do that for this type of system. Thank you for your attention.
Really good IT. So, okay, no, I'm very happy that we have concluded this broad session about the alternative supplies of the energy for the trains this afternoon. Are there any imminent questions from the audience? Or is everyone super happy with what we have been presented by the speakers? I don't see any, but I would have obviously few. I mean, back to what you just presented. You seem to be ready to standardize everything. Like everything is ready and everything is on the market. So my question obviously would be, I mean, now we are going to see the hydrogen JU, so hydrogen joint undertaking under the Horizon Europe in place established. Do you need them? Because if you have everything, why do we need still to develop anything?
Well, the question is, do we need regulation when we have standards? Maybe.
You answered that.
I would say that, yes, the basis is to have a clear standard. This is really the key challenge. If we want that this standard to be applied in an uniform manner in a certain region of the area, we need regulation for that. That's for sure. But the basic point is to have good standard and good agreement with these standards as the first step.
Okay, that sounds good. That sounds good. Now, Alstom SNCF, I mean, are you compliant with the standards that they are now going to put in for? You are, simply. There is no problem. Everything is fine. Everything is ready. So back again to my previous question. Do you need the hydrogen JU? Yes. Yes. Then tell me why. Because you are also part of the Europe's region undertaking. So, but are you also participating in the hydrogen GU?
Me personally, not.
Not I mean personally, but you have a company behind.
But yes, my company is working on both topics. Yeah. Europe's Rail GU and hydrogen GU, and we need both because I understood that if we want to develop a specific application for railway, we need to do it maybe on the scope of Europe's Rail GU, but the standardization and many things can be developed in hydrogen GU, in fact.
Okay. So do you still have a good hopes for what the
yes, we have a hope, yes, because we need some money also and fundings and so.
Related question to that, because you are producing the trains of the various kinds, including the battery, electric, so the hybrid.
Yes.
What is the rough estimation? Maybe it's a stupid question, but the efficiency
well-to-wheel of the diesel, electric, battery and hydrogen? Do you have any answer?
Yes, we have an answer. I saw a paper and they said that the electric system, the efficiency is 95%. But in fact, you have to take into account
No, but that's why I said that
the
well-to-wheel
production,
and not
yes,
just
of energy.
engine-to-wheel,
That's and in fact, there is no miracle. The global efficiency is almost the same.
Quindi sei d'accordo che dobbiamo modificare la frase, insomma.
It's true that for hydrogen, we have more steps, and so the efficiency at this moment is lower. In the
compared to the electric.
Yes, that's true.
Okay, but you still hope it's going to be better in the hydrogen
They have advantages and disadvantages on all systems. So
okay, good.
that's the point.
Thank you very much. Now I have to go back because I promised that I will go back to Bart and asking what Domenico has presented. I mean, what's your assessment? Are you going to use it? Do you use it already? What is the accuracy of the measurement, the certification of the product?
It's more for the RUs that can use it, of course, if they want to have more power quality measurements on board. What Domenico presented is a compliant EMS, but with adding extra functions to monitor the power quality of your overhead contact line and detect, for instance, the arcs and things like that. So it's complementary.
Okay.
I have a question regarding the hydrogen. Is it, because you had a test cycle with 20% up to 80%, is it not better to use the hydrogen fuel cell as a base load and use, for instance, supercaps for accelerating? Or was it included fuel cell with the extra tools, or was it just the fuel cell that you're going to test from 20% to 80% to 20%?
Sorry, you have to come back to the micro.
Yes, thank you for the question. In fact, when we talk about hydrogen train, for sure we use hybridization with battery, and you're right. In a very high level, we define what is the average power of the train needed on the track, and the first step is to say, okay, this average power will be provided by the fuel cell. And peak power will be provided by the battery. So at the very basic step, we use this kind of hybridization strategy. And just regarding the slide I have presented, it was just one extract coming from another power profile because we are just at the early stage of the discussion. But you're right, probably there will be less power modification for the fuel cell, and we try as much as possible to use the fuel cell in the same power range to improve efficiency and also to improve the lifetime of the fuel cell itself. We mainly use a battery, but we are also checking for supercap solution. It depends about the track characteristic and so on. Yes. In fact, we use the battery for peak power, but we also use the battery for energy recovery during braking phase and so on.
Right. By the way, the supercapacitors on your trains?
No. No, for original trains, the solutions we saw are made with batteries, so hydrogen train and battery trains. But yes, if we want to talk about suburban trains, there could be a very interesting usage of energy storage system under catenary. In fact, to reduce the cost of investments in infrastructure, substation, for example. And we could use there supercaps and batteries because we have full power, full braking every 2 kilometers, and supercaps are very interesting in that system. Yeah. So, but it's fully electric trained.
Okay, sure.
If I may just complete your question regarding supercaps, we do use supercaps, but only for tramways. We use it, for instance, in Rio, in the studies for Rio, we use the supercaps just to go through the crossways with cars. And we also use supercaps, lithium caps, in fact, in Nice. The second line of Nice is fully with lithium caps, and we have recharging 1,600 amps at each station. And I close the parenthesis. So at each station we refill the supercaps in 20 seconds, and we go step by step like this.
Okay. Which brings me to my almost final question, but to Paul, because you mentioned that you still have a discussion with the agency about the compliance of the overhead contact line with regards to the charging of the battery, or now maybe also the supercapacitor trains. Why there is a discussion? I mean, are there any objections against what you need to do in the TSIs to have them updated in accordance with the needs for charging the trains? I mean, who is opposing? Simply as simple like that, you know? I mean, you have to come here. And what is...
I'm afraid I'm a technician. And sometimes we need lawyers. It's really discussions about the legality.
Just the legality, so there are no technical objections?
No. But the technical issue on the charging at standstill is that what we are obliged to do as infrastructure managers is not much. That's not sufficient. For 3 out of 4 target systems, even 15 kV is limit. That's not technically not sufficient to charge the battery trains. Because what is a battery train? All these documents are written with a direct link between power consumption and power generation. Your overhead contact line is just a long line, and the battery is just breaks that link. And so there is some discontinuity in all the calculations, how you calculate your power supply, and things like that. And so that's why at standstill we want to charge, because the train is only standing still, maybe in a station for one or 2 minutes. So we want to charge more than we are now obliged to do. And certainly for the DC systems. For France, 1.5 kV in southern France, you need the amount of current that you need at standstill to fully charge your battery is far too big for just the systems we know now.
I understand that there are technical obstacles, but I still, wish to understand better, but maybe for a separate discussion, what's, on the issue with the agency. But okay, let's discuss it.
It's not an issue with the agency. This is maybe in standardization and regularization. Everybody reads the same text and understands something different.
Ideal. But yes.
I have an additional point on that topic. So in Europe's rail, we have proposed to work on the data flow between the train and the ground, the substation, for example, for a battery train, because, for example, if you have 10 regional trains stand still in the same place and they want to charge, all of them want to charge at the same time, maybe it's not possible, and maybe it's preferable to select the one which will start the mission earlier than the other one. So we have to define rules to select the trains, and from the operator point of view also, from the desk, they need to be able to interrogate the trains to know what is the state of charge and does the train is able to realize the mission or not. So we have to work between infrastructure and rolling stock to define all of this so that we can charge and discharge, why not, the battery trains on demand from the ground.
It's very complex. You wish to continue. Go ahead.
I can add that we will start in January. I just filled in the doodle during the meeting this morning with a group on checking on the energy functions that should be automated and where we need interaction with CCS, TSI, and likely with automatic train operation and communication towards driving advisory systems as a way on how to solve. And this will also be suitable for the charging of the battery trains, but yeah, it has to start. Yes. But of course, ATO and DAS already have some functions. A lot of it is already in.
Good. I know we have to, no, sorry.
One more question.
Of course, because I hope we still have a Carlo online. Carlo, are you with us?
Carlo?
Carlo?
I am.
Perfect, because I have one provocative question for you.
Video, Carlo.
Carlo, you mentioned that you expect that a new emission trading scheme is going to involve or engage also the road emissions. And
Yes.
I remember well, that was a never, I would say, ending discussion we had in the context of the previous revision of the ETS, and road was, it was impossible to include it in. So what brings you in the, I would say, dreaming about this road in the ETS in the new version?
Well, first and foremost, road is not in the actual ETS, it's a new one, so there's a difference. In the actual ETS, anyhow, we move forward in terms of phasing out free allowances for air transport and including maritime. In the new scheme for road and for buildings, that will have ad hoc also mitigation measures for the impact of the population, notably not just to pay them back, but to facilitate the transition of the alternatives to road transport, which is a part of the package. There's also an issue that, in a way of implementing it, we came to a vision that will not be actually implemented as an individual tax that would be not feasible, but will be actually added on the energy sources, so if you wish, on the fuels, actually. Eventually used in buildings and transport. This is also making it more feasible and more gradual in the phase-in. But of course now, this is a breakthrough which was possible because an incredible amount of things has changed since 2018 to now, to Glasgow, and there is momentum, and the Green Deal has dramatically increased the ambition we have. And so there will be this measure, and this measure is conceived in a way that will discourage an intensive use of private internal combustion engine cars. And it's actually addressing something which is very inefficient, if you wish, from the point of view of economics, which is a system where you pay very high fixed cost and then a very low variable cost, and you don't pay external costs. So basically, you have the interest of using your car as much as possible, even if it's in a congested urban environment. You run it for yourself, and you basically throw away, considering your weight, the weight of the car, 99.5% of the energy. This is not very efficient, so we want to make it more efficient, but we want also to offer people to be compensated for the changes they are incurring, for the transport energy poverty, and giving them the opportunity to shift towards something better.
Okay, no, that explains. Okay, thanks. That's an approach I hope is going to materialize at the end. Thank you. Thank you very much. Thank you to all the speakers here, but please do stay here because now it's back to Paolo.
So back to Paolo is going to call a few people, so if you can stay on the stage. And then I would like to invite to join on the stage the speakers from this morning, as well as Daniele, if it's possible. So Daniele, Philippe, Libor, Jean-Michel, as well as Paul, Yannick, which just left, Philippe, Bart, Denis, and Julia. Okay, all here. Paolo. So as a little thanks, Paolo is going to offer you a little present to remember Toulouse. So it's a consumable present. So try to keep it until Christmas, if you can. So once again, thank you to all of you speakers from today in this beginning of the day. Let's say we are halfway now, and we are going to make a little break afterwards, and then we will enjoy the panel 3 with digitalization. So now we will invite you to have a little coffee break for 5 minutes, if you can, please. Thank you.
When you're here, you'll discover this. You'll indulge in this, this, and this too. You'll explore far beyond. You'll have great encounters in really magical places. You'll run around or take a walk. You'll feel the vibes. You'll immortalize your memories here. And we'll share all that. There you go. When you get here, we'll be waiting. Toulouse à tout.
Un, deux, okay.
Building and configuring the onboard Ethernet network on modern trains is a complex and time-consuming activity. Several hours are often required to properly configure the onboard network and check for proper cabling connections, making the initial network setup a costly activity. Any action that can be taken to reduce the time should be encouraged. What if it were possible to dramatically reduce setup time and increase organizational efficiency? VDS Rail TTC-MP Network Toolkit makes this possible. Thanks to TTC-MP Network Toolkit, network engineers can easily and quickly set up the onboard network. All consist Ethernet switches are automatically configured from a single network project file shared among all switch nodes, accelerating commissioning time. Network engineers use the TTC-MP Network Designer graphical user interface to define the network project in a single plug-and-play profile. This network project profile is then exported in a file and shared on the network. Field engineers use one of the TTC-MP tools to introduce the network project profile into one of the consist switches residing on the network. TTC-MP services automatically distributes the network project profile to all switches. Every switch composing the network receives its own configuration by extracting it from the project profile file. all switches are automatically configured and become fully operational in a matter of minutes. The same procedure can be applied to replicate the same network configuration on each fleet vehicle composing the consist. When the train is fully operational, TTCMP Network Toolkit can be used to monitor and troubleshoot the consist network. TTCMP Services continuously checks that the current network is reflecting the proper project profile. If not, an error notification is displayed. In the event of a device failure and replacement, TTCMP Services plug-and-play functionality detects the replaced switch and automatically updates and restores the project profile configuration, dramatically reducing network and vehicle downtime. VDS Rail TTCMP Network Toolkit ensures significant time and cost savings in each phase of the onboard network implementation and commissioning. To learn more about VDS Rail TTCMP Network Toolkit, visit our website at www.vdsrail.com or send us a request email to sales@vdsrail.com.